Hi, and welcome to the final lesson in this course on R programming. This video is going to be a little bit different from what we've done in the past. In all of our previous videos, we've focused on a certain topic or a certain function, but in this video, we're going to look at combining all of our skills together to work on a problem. Because most of the time when you approach a data problem with programming, you're not going to only need one skill. You're going to need to draw on a lot of different skills in order to solve that problem. So in this video, what we're going to do is we're going to look at the huge volcano dataset that we downloaded in the second week of this course. And I'm going to walk you through how to go from a huge dataset like that one is to a couple really nice graphs. And at the end of this video, I'm going to set you up with two final projects. And the projects are going to be to make two specific graphs. And I'll show you pictures of the graphs and then you will go off and make them. But what I really want to show you in this video is how you work through the process of starting with a completely unedited data set and going to an edited, cleaned up data set that you can then graph. So I'm going to really walk you through my own process of doing this, just so you can get an idea of what you should be doing as you go from the unedited to the edited versions. So the first thing I always do is I open up my data in a separate window, just so I can get kind of an idea of what it looks like. And we did look at this a couple weeks ago, but I'm just going to walk through it again today. So this data has 13 different variables, so 13 different columns as we can see up here. And it has 1,556 rows, which we can see up here and also down here at the bottom of our script box. So as I look at this data frame, a couple things stand out to me. When I start to plan out what I'm going to graph from this data frame, I want to look at what columns I think are going to give me some interesting things to look at. And really more importantly than just being interesting to look at is which variables I can graph easily. So for example, volcano name is not something that I'm going to be able to graph easily. There are 1,556 different volcanoes in here. So to put all of those along an x-axis would be pretty crazy and you wouldn't really be able to see anything from that. So I'm going to stray away from volcano name. That's useful if we're looking at an individual data point, but not so much if we want to make a graph of this entire data set. Country is definitely a viable option because unlike volcano name, this repeats itself. So what I can do is I could get the average of something for each country. I can condense this data in some way to make it easier to read. Primary volcano type is also the same because it's got categories, so I can see that this repeats itself. So I can group those. Last known eruption, while that is really useful and I can see being able to make a really cool graph from it, R is unfortunately not the best with dates, especially since you see we have a number and a letter in here. So if it didn't have these letters, B, C, E, or C, E, it would be much easier to graph because then I could treat it as numeric data and just graph it from least to greatest or something like that. But as it is, it's a combination of these, so it would be very difficult to graph. If you want to go off and do something with the last known eruption column, there are a bunch of packages that help you deal with dates, but we're not going to get into that today because it's a little complicated. Region and subregion are also both possible options for graphing for the same reason that countries are. Latitude and longitude are also things that you could go off and explore on your own because there are R packages that deal with latitude and longitude variables, but we're not going to do that today. Elevation immediately stands out to me because it's just a numeric, and that's something that I could definitely graph. And dominant rock type also stands out for the same reason that the regions and the countries and everything stood out to me. So now that we've looked at our data a little bit, I'm just going to pick 3 of those columns that we're going to focus on in this video at looking at graphing. I'm going to choose primary volcano type, elevation, and dominant rock type. And the first thing I'm going to do in my code is I'm going to load these 3 libraries because from practice I know that most of what I'm going to do is going to be within these 3 libraries. ggplot2 for the graphing, and then plier and reshape2 for all my data manipulation. So I'm going to run these. And then what I'm going to do is run names of volcano data. And this is so that I know the exact spelling of all the columns without having to view the volcano data and look at the column titles. So now that I've gotten to look at the data in spreadsheet form, I'm going to now make just a really basic graph just to get an idea of what the actual numbers look like. And for here, I'm going to look at the elevation for all the different volcanoes. So I'm actually just going to put volcano name on the x-axis just to look at the elevation data for everything. Because even though you recall I said that we weren't really going to use volcano name because there were too many options and it would be a confusing amount of data, this is just to kind of get a look at it. And then I'm going to have the fill of all the bars be by dominant rock type. So this is really just to get kind of an image in my head of what this data will look like. And you notice that this takes a lot longer to graph than other things that we've graphed before because it's such a huge data frame. So I'm just gonna zoom in a little bit so we can see this a bit bigger. And the other reason that I've done this with all of the volcanoes is because I also want to look for errors in the data, for things that I'm gonna have to edit a little bit. And I immediately see a couple of things. So the first thing I see is that there are two dominant rock types here. One is red, and it doesn't have anything written here, and one is no data. What this red tells me is that there are rows in the dominant rock type column that don't have any values. So those are rows that we're going to want to get rid of. So that's immediately something I see that I have to edit in the data frame. The other thing is no data columns. We also don't need to graph volcanoes that have no data for dominant rock type. So I'm also going to strip out rows that have no data listed. And another thing I'm going to do, because if you notice, you saw this warning message, R doesn't really deal with these values down here very well, values less than 0. So I'm also going to strip those out. So any volcano which has elevation less than 0, I'm going to take out of our data frame. We could leave those in there actually. R can do them, but we're just going to do it for practice. Now we're going to remove all the rows where the elevation is less than 0. So we're going to make a new data frame called clean volcano data. And into it, we're going to save volcano data when elevation is greater than 0 for all the rows. So this is just the row, comma, column syntax. And now if we want to check that this worked, we can go back up to our original code and we can instead put in clean volcano data. Now if we run this, it should have no values under the x-axis. And I see that it's worked because we have no values below 0. So that's great, we fixed one of the problems. Now I want to fix these missing values and the no data rows. So it goes off my screen a little bit, so I'm going to make this really small over here. So now we're going to remove rows where there are no dominant rock types and rows where there's no data. So I'm going to do this in 2 lines, and I'm just going to save over the clean volcano data frame by saying clean volcano data frame when it's not, with this exclamation point, dominant rock type equals no data checked. So that's the name of this variable that I want to remove. So this is saying I want all the rows where it's not this. So that's just removing this variable. Now the next one is a little different because if you remember back in our previous video talking about replacing values and stripping out values, I did is.na, but here I'm doing something a little differently. Because there's simply no value in that box, what I can do instead is say, do the exact same thing as I did up here in this row, but leave nothing within the quotation marks down here. So that's just saying when there's nothing in the box, take it out. I'm going to run both of these lines, and I'm going to view this data frame to see if it worked. So I'll go over to the elevation column, and it looks like there's nothing in negative numbers. Perfect. And then in dominant rock type, I'm just going to scan really quickly for blank rows, and it looks like there's nothing there. So I think we're good. So now I'm going to graph this again just to make sure that it's worked properly. And now I can see that I've removed those blank rows, and I've also removed all the rows that say no data. So now my data is all cleaned up and ready to do some different things with, because this graph isn't the best. There are too many bars to be informative. The first thing I'm going to do to clean up this graph is remove the x-axis labels. These gray bars down here are actually the labels because they're each of the volcano names, but there's so many of them that they overlap each other. So that's a little less confusing for this graph, but it's still not perfect. It's still not telling us anything. So I'm going to try something different. I'm going to try using the facet grid function to give us something a little different. And what this does, if you remember, is it separates out your graphs into multiple graphs based on a factor. So here I'm separating it based on dominant rock type. Now this is a little more interesting. It's kind of cool to see. I'm going to zoom in so you can see it a little better. It's divided it up into a bunch of different graphs this way. Each of these vertical lines is a different volcano, and then it's mapping the elevation. So this is kind of cool, but this also doesn't really tell us much. There are too many little lines. It's not very informative. It's just kind of cool to look at. So what can we do to make this more informational? Well, what if we tried a different kind of graph? This doesn't tell us so much by itself, but what if instead of counting each individual volcano, we were counting how many times a volcano elevation and rock type combination happened? So in other words, what if we did this as a histogram instead? So what if we said the X is the elevation and the fill is the dominant rock type? Now this is a little more informative because, let me zoom in here. Because now instead of the elevation, the y-axis is the count. It's the number of times this combination happens. So the elevation is along the x-axis, so it goes from low to high, from left to right. This is kind of interesting. This is actually telling us something. We can see, for example, that volcanoes with andesite and basalt rock types tend to be lower elevation and then slowly taper off. So these have kind of patterns. Dacite is spread out all along the spectrum. And there are a few where we don't have many volcanoes at all. So this is actually telling us something, in addition to being interesting to look at. So I'm going to focus in on this graph a little bit, because the data seems good, but now we need to edit some of the aesthetic parts of it. So the first thing I'm going to do is remove the legend, because it's a redundant part of the graph. We already have the rock types listed along the side here, so we don't need this as well. So with the theme add-on saying legend position equals none, I'm going to remove that legend. I'm going to change the X and Y axis labels to be something more descriptive, and then I'm also going to add a title so that the people looking at this graph will be able to more easily tell what it's of. So now if I zoom in, this is already a much better graph. It's got more descriptive axis labels, it's got a title that tells us exactly what it's showing, and it doesn't have that redundant legend. And it can actually show us trends in the data, as opposed to just being a whole bunch of data on a graph like it was before, not separated out or anything, and not really telling us much. So in this video, I've kind of walked you through what I do when I approach a data frame. The first thing I do is I open up the data frame in a spreadsheet, kind of look through it to see what I might want to graph from it. Then I'll try making a very basic bar or scatter plot just to kind of see the trends in the data, to get kind of a picture in my head of what the data looks like. And then I'll try messing around with that graph to make it look prettier, maybe try manipulating the data a little bit. So now that we're coming to the close of this video and of the entire course, I'm going to set you two really big challenges. These two challenges are going to require you to use pretty much every skill that you've learned throughout this entire class. You're going to need to use ddply and melt and subset your data frames and do different kinds of graphs and change a whole bunch of different elements of those graphs. So my challenges for you are to make two different graphs. Your first graph is you're going to get the average elevation for each dominant rock type and then make a bar graph from that. Then I want you to change the levels in the data frame itself so that the bars in the graph go from least to greatest. So the bars should be small on the left and get bigger as you go to the right. And I want you to make sure, like we did in this video, to remove rows where there are no dominant rock types and rows where it says there's no data. So I've already given you a little bit of a head start on that because you can just copy the code that I've done in this lecture. Your second challenge is going to be a little bit harder. You're going to get the average elevation for each dominant rock type and for each primary volcano type, and then make a scatter plot with that. So if you're having a little trouble with this, I recommend that you rewatch the ddply videos because you're definitely going to need that for both of these challenges. And here I'm going to show you what the final product should look like. So these are the two graphs that you're going to make. Your first challenge graph should look somewhat like this at the end. It's okay if it's slightly different, like if you don't make the bars a little bit transparent, that's okay, but really it should look almost exactly like this. You should have dominant rock type on the bottom, and then you should have average volcano height on the y-axis, and the bars should go from least to greatest. And I didn't do this in this picture, but if you want to, you can also go in and change the legend title so that instead of having a period between dominant rock and type, it's just dominant rock type. Your second graph is going to be more difficult to make. The first graph, I've already set the groundwork for it in this lecture. It's not a huge leap to go from this video to the first graph. But the second graph is different. This is going to be a scatter plot. And what I want is for you to have only these types of volcanoes, the ones along the x-axis. So you're going to subset your data frame so that you only have those types of volcanoes. I want the average volcano height along the y-axis. And then I want it color-coded by dominant rock type. And lastly, as a bonus graph, if you want to take this and use the facet grid function to make it into multiple graphs, that's like your bonus extra points graph, because I think this looks pretty cool as separate graphs. But you do not have to do this final graph. It's just an extension of the second graph. So for this challenge, you're going to have to do a bit of research probably. Any online resource is open to you to use. You should use your notes, the R cookbook online. You should refer back to these videos. Really anything that will help you, you can use. And feel free to talk about the answers in the comments, talk about problems you're having, and we'll all help each other work out the kinks in our graphs. So in this video, we've walked our way through a huge data set, how to go from a completely unedited huge data frame to a cleaned up one that we're able to graph in a meaningful way. And we've also gone over the final challenges or final projects of this course.